Let me briefly introduce myself. My name's Richard Carter. I've been working in the rural water sector for 49 years now, so quite a long stretch. Um, and one of the constant concerns that I've had in the last 2 or 3 decades has been the fact that so many water systems break down and stay broken down for too long. So I've become quite obsessed with the whole notion of sustainability and reliability. Um, I will be moderating the webinar that is trying to lead us through the program and supporting the Q&A session and the discussion at the end. So we're going to hear from 5 individuals. We'll actually have 6 short presentations. So we'll take them quite briefly. I'm not going to make long introductions of the individual speakers. I think you have their fuller bios somewhere else. But we have representatives from Design Outreach, from Poldaw, from Fisherman's Rest, and we're going to hear from each of these individuals and as we go through the various presentations. So let me, without further ado, kick off the first presentation. This is from Michael Cook. Michael is with Design Outreach, and he's the Engineering Solutions Director. Over to you, Michael.
Good morning and good afternoon. Thank you so much for joining this RWSN Stop the Rot webinar. This slideshow shows the presenters and moderator for today's webinar. And my name is Michael, and I'm the Design Outreach Project Lead for the India Mark II and Afridev hand pump upgrade project. As we look into the question of, can technical innovation really increase hand pump functionality? I want to give a quick introduction to this hand pump upgrade project and say a huge thank you to everyone on this webinar who have been working together toward improving the reliability of public domain hand pumps. The India Mark II Afridev hand pump upgrade project started off as a partnership in 2022 between Design Outreach and Poldaw Designs, formerly known as Neil Consulting Engineers. And since then, we partnered with many others around the globe to help improve the reliability of these very vital public domain hand pumps. So you might be asking, well, why Design Outreach and why Poldaw Designs? So to give you a little background, since 2010, Design Outreach has been immersed in the persistent issues of public domain hand pumps, conducting research, attending conferences, interacting with RWSN and field partners, many of whom complement the India Mark II or Afridev pumps with a DO life pump. And we visited many of the communities in the 14 countries where DO works. Also, as an organization, DO has grown significantly in the past 5 years, with staff increasing from 5 to over 30 full and part-time employees. In addition, DO has built an extensive network of volunteer engineers and designers, many of whom are experts in their respective fields, and also industry and academic partners and field implementing partners. Poldaw Designs, they've carried out pro bono design and development work on appropriate technology devices since 1984, including wind pumps, which were manufactured locally in more than 10 countries, and hand pumps as well. Their current focus working with WaterAid is improving the India Mark II, in particular in terms of corrosion issues, reliability, and maintainability with a project in Uganda. You also may be wondering, how is this project funded? Well, it's funded a variety of ways through a private donor base of individuals, churches, charitable foundations, and organizations who support the ongoing work of Design Outreach. Now I would like to mention some of our project partners, some whom are listed on this page, and there are many others. So first of all, we participate in the RWSN Stop the Rot Action Group, and we're very thankful to the RWSN team for making this webinar possible. Also, a huge shout out to Fisherman's Rest and the Monze Lipo team for all the Afridev field testing they've done on the Poldaw floating centralizer and many other components. Thank you. We also have working relationships with others, including universities and other organizations who are experts in the water arena. Our goals for this project are fourfold. First of all, we want to improve the repair interval on fast wearing parts from 6 months up to an average of 2 to 3 years. And then we want to make sure that expensive parts that require major repairs last 10 plus years. Some of these should actually last 20 years. And we also want to eliminate corrosion from pipes and excessive lead and iron from the water. And then last but not least, we want to advocate for an update of the IM2 and Afridev standards with these upgraded designs. During our June 6, 2023 Stop the Rot webinar, I presented some preliminary data from our hand pump reliability questionnaire. Now, the reason for this survey was to get a better understanding of what specific hand pump components are contributing to early failure and help us set project priorities. So as of that date in June 2023, we'd had 208 responses from 26 countries. And by the time we closed out the questionnaire, we had 276 responses from 34 countries and regions. So first of all, I want to give a huge thank you to everyone who helped with this questionnaire, both those who responded and answered the questions, and all those who helped spread the word and make it happen. So today I want to give you a brief summary of the questionnaire results relating to some of the short life components and how long the respondents think these components will last. This chart shows a list of Afridev components that we consider short life components based on the questionnaire results. So if you look at these columns, the first one is pump rod guide wear out, or also called centralisers, of course, showing an average life of 3.5 years based on the survey results. The rubber bucket seal is showing an average life of 1.2 years. And then the plunger and foot valve are showing average lives of 2.3 and 2.8 years, respectively. And then the handle pivot bearings in the last column, that's showing an average life of 1.4 years. And I'd like you to draw your attention to the first column showing the centralisers lasting 3.5 years based on these responses, because I'd like to refer to that later. Although this chart looks similar to the last one, this is actually showing the components of the India Mark II and III that we believe have short lives based on the questionnaire responses. You can see in the first and second column, riser pipe breakage and leakage both show an average life of 3.1 years. The third column shows the average life of the rubber bucket seal, also having an average life of 3.1 years. And the fourth column shows the handle pivot bearings having an average life of 3 years. And then the last column shows the chain having an average life of 3.4 years. So I also want to say thank you again for all you who helped complete this questionnaire and give us this feedback. And I want to give you the heads up that we plan to publish more details from this questionnaire in the coming months. Thanks again. Remember, back 2 slides. Good morning and good afternoon.
Thank you very much, Michael. We're going to move on to the first of two presentations, short ones, from Sandy Pollack, who's going to take us into some more of the technical detail of the innovation that we're talking about today.
Hello, I'm Sandy Pollack. I'm going to talk to you about the floating centraliser concept. I'll start by talking about the problems with the current rubber centralisers, including secondary failures. Then I will go on to describe the floating centraliser and take you through the history of development and testing of this new innovation. In the main picture on the left, you'll see 3 centralisers. Of these, the leftmost one is the type used with threaded rods, and the 2 next to it are the types used with hook and eye rods. The one in the middle is a heavily worn example. You can see that the edges have got quite thin, whereas the one to its right is a brand new sample. You can see the sort of standard barreled shape. On the top right of this slide, you will see a badly worn example which has started to break up. Particles of rubber have detached from this, and we'll talk more about that later. And in the bottom right, you'll see 3 further examples. These are all the type that's used with the threaded rod. The one in the middle on this picture is a brand new one, and the 2 lower ones beside it are ones that are substantially worn. So, what happens when the centralisers wear or fail? Well, the first and most obvious direct consequence is that the pump rod joints can start to scrape against the inside of the riser pipe and cause the pipe to fail. And I think that's well known. However, there are also a number of indirect consequences. These occur because particles of rubber detaching from the centralisers will sink down the riser and potentially cause problems with the pump cylinder and the valves. So we have seen examples where these fragments of rubber falling down cause rapid wear of the plunger cup seal and also increase the friction at the plunger. That can cause reduced water output and a higher operating effort for the users. In extreme cases, the plunger actually becomes jammed in the cylinder because of all these extra particles of rubber sitting around it. The foot valve and the plunger valve, the rubber bobbin that moves up and down in the valve, may become disrupted or jammed so that the foot valve either leaks or doesn't function at all. And we've also quite often found that when you're trying to do a repair, particles of rubber are sitting around the foot valve below the plunger and stopping you from extracting the foot valve using the normal foot valve fishing tool. So a lot of these consequences result in you having to pull out the pipes, and the pipes may be full of water and therefore very heavy in order to repair the system. It's been estimated that between 70% and 80% of the repair costs of Afridevs are ultimately caused by rod centraliser problems. This estimate has been produced by Fisherman's Rest Madzialipo from analysis of their database of maintenance and repair records. Now for the bit that you've been waiting for, the floating centraliser concept. The diagram on the left is a representation, simplified, of the cross-section through the pipe. So the pipe is the blue lines, the pump rod is the grey piece, and at the top of the pump rod you can see a rod joint. The purpose of the centraliser is to stop the rod joint from contacting the inside of the pipe. The centraliser is shown in orange, and you will notice that the centraliser is not attached to the rod joint. It's actually sliding, free to slide on the rod itself. The material of the centraliser is ultra high molecular weight polyethylene, or UHMWPE, which is a very good material for this operation, partly because it is low friction, but partly because it is slightly less dense than water, so it tends to float upwards. The centraliser is free to slide on the rod. It can slide up and down on the rod. It's also free to slide up and down relative to the pipe. What happens in practice is it tends to migrate to a position just under the rod joint, as shown in the diagram on the left. It sits in that place And the sliding that occurs as the rod moves up and down is mainly a sliding action between the rod and the centraliser. The centraliser tends to stay more or less in one position relative to the pipe, and the rod moves up and down through the centraliser. This means that the sliding action is between a smooth stainless steel rod surface and the centraliser material, and that leads to low friction and low wear of the centraliser. Our projected life for this is between 5 and 20 years. 5 years in a very severe operating environment with perhaps a severely bent borehole, 20 years in a more benign operating environment. On the right, you'll see two versions of the centraliser. The blue one at the top is what we call the snap fit version, which is suitable for the Afridev hook and eye rods, and we will talk more about that later. And at the bottom, you will see a black piece, which is a simple type that works with threaded rods. So the black piece is analogous to the orange centraliser shown in the left-hand diagram. That's what it looks like. It's just a cylinder of material with a hole in the middle, and it slides freely on the rod. I'm going to very briefly take you through the history of development and testing on this. We started with it in 2004, 20 years ago, and it was used on the Poldaw ultra deep hand pump, which was field tested for about 4 years, and there were no problems with it. Moving on about 15 years, it was then used on 6 modified India Mark II pumps in Uganda. This was introduced here because of severe problems with the standard rubber centralisers. And again, it ran for, well, it's now run for 5 years, but they were inspected in 2023 after 4 years operation with very little wear noted on the centralisers. In 2021, we devised a snap fit version for use on certain types of pump rods, and that is the one we are now using on the Afridev. Following on from the Uganda project, 2023 to 2024, a further 100 modified India Mark II pumps have been installed with the floating centralisers, and they're all working fine at the moment. And in 2023, the snap fit version, the subject of today's webinar, was initially tested on 8 Afridevs in Malawi by Fisherman's Rest, and those have now run for more than 15 months and have been inspected recently, confirming very little wear. And in the last year, over 140 Afridevs in Malawi have now been fitted with the snap fit version, mainly by Fisherman's Rest and some recently by Design Outreach. And right now we are in the final stages of preparing production tooling to be able to offer these devices in quantity early next year. Hello.
Okay, thank you very much for that first presentation, Sandy. We are going to move on to some of the field testing now that you were just referring to, field testing that's been carried out quite extensively by Fisherman's Rest, and Harlod Zaunda is going to take us through that in a moment. I'll just add one point right now, which we can pick up on later in the discussion, and that is to point out that in practice, the life of some of these centralisers has been observed to be quite short, much shorter than indicated in the questionnaire that Michael presented in the first talk. But let's pick that up later. We're going to hear from Harlod now about some of the results from the field.
Welcome everyone. My name is Harlod Zaunda. I'll be presenting on fisherman's race field testing experiences. So basically, fisherman's race who was granted access by Blantyre District Council to upgrade 200 pumps in Tesomba. So the pilot started in August 2023 with starting with 10 white machined floating centralisers. So we are able to monitor each installation on Mazaripo management system. So from the 200 pumps, we have done 63%, where we have fitted 1,327 floating centralisers with an average of 10.5 per hand pump. So the longest time in service is 456 days, and average time in service is 120 days. So together with the Blantyre District Council as well as the Minister of Water and Sanitation, Regional Water Office South, we have done 9 joint installation visits as well as 6 inspection visits. So this is a floating centraliser that was being installed, and laba centralisers that were replaced. And we can see that the communities, together with the Mazaripo team, we are carrying out the task at one of the communities in that picture highlighted. So what has been the major key lessons that we have learned? So as Mazi, we have observed that the floating centralisers are very easy to install and uninstall. And the floating centralisers have also significantly reduced our repair cost caused by the broken rubber centralisers, possibly by an estimated 70 to 80%. And there has been reduction in Mazaripo being called by the communities to assist repairs by an estimated 80%. This is applying to stack or jump blows. For example, there has been an average of 26 major repairs per year in Tesomba over the past 6 years, where we have been called to assist the communities. That is due to the broken rubber centralisers, maybe which jammed the rows as well as the foot valve assembly. So compared to the past 6 years, in 2024, we have just been called to 5 hand pumps. And we have also observed a functionality increase in Tesomba, that is from 92% in May 2023 to 96% in September 2024. However, the 92% functionality is attributed to Mazaripo hand pump repair program in Blantyre Rural, where it includes Tesomba, while 96% is attributable to the uptime project, and maybe part of it can be attributed to the fitted floating central. Another lesson that we are learning is that the floating centralisers that are very durable do not disintegrate as compared to the rubber centralisers. There has been some issues where we have been facing challenges with the rubber centralisers because of their disintegration. However, we have also seen no noticeable wear within the 3 months of installation for these floating centralisers. And during one of the installation visits, there was a comment from one of Mazaripo field officer, Poldaw, and I quote, "These floating load centralisers are ideal for people in rural communities because they save money that would otherwise be spent on frequently purchased rubber load centralisers, as these floating centralisers are very durable. Therefore, money can be saved. The community can be used to buy other essential hand pump parts necessary for their pumps." That's according to both Karime Mazaripo field officer. So to him, the communities can be able to save money that is frequently used to buy those rubber centralisers, because they no longer need the rubber centralisers frequently, just because we have those floating centralisers that are very, very durable. And there's been also government observations with the floating centralisers during our inspections as well as joint installation visits. At one time, Patrick Chimara, former assistant hydrologist at Banda District Water Office, had this to say, and I quote, "The floating centralisers have not shown any defects and seem to be reliable. We have to continue monitoring them, but I believe they will stay for years since they have shown durability over the past 8 months." So according to the assistant hydrologist, these floating centralizers seemed promising after 8 months of installation. So that was one of the visits that we conducted and he had that comment. And basically, there was also a comment from Chief Community Water Supply Officer, the Minister of Water and Sanitation, that's the Regional Water Office South. And I quote, "The floating centralizer seem promising. Now we have to see how to make the parts available to local Malawians at an affordable price." So to the Chief Community Water Supply Officer, the floating centralizers were good, but also the concern was how to make them available to the local Malawians. So as government, they have also reservations on the making these parts available to local Malawians. So these are the white floating centralizers that has also explained that the first 10 were piloted in Tesomba in August 2023, and after 8 months, nowhere were observed in them. Right now it's about 15 months since in service, and we have observed nowhere. So thank you very much.
Well, thank you very much for that, Harlod. We'll move on to hear now from Jeremiah Sakala, who's with Design Outreach in their Malawi field office. Jeremiah, it's over to you.
Good morning, good afternoon, good evening, depending on where you are listening from across the globe. My name is Jeremiah Sakala. I'm a field engineer for Design Outreach based in Malawi. So today I'll present about the new road centralizer for Afridev pumps that has been tested in some of the boreholes in Malawi. So after the development of this centralizer, I think you've already heard about it, we try to negotiate or collaborate with WHH, who have some interventions in the Dzaleka refugee camp. So they have a number of boreholes in there, and it was reported by one of their technicians that most of these boreholes require regular maintenance almost every month. So we selected 2 pumps, and 1 pump at Katubia in one section of the camp required the changing of road centralizers and capsules almost every month, sometimes twice a month. So once we fitted the new centralizers on 16th of May up to October, 5 months on, there was no need to change either the centralizers or the capsules. So on October 4th, we went back to the camp and we removed the centralizer just to check how they had performed over the period. It was expected that centralizer wear patterns were, as expected, centralizer wear patterns were observed and were indicated the high use of the pump. Centralizers were put back and will be inspected periodically to see how much wear will be on the centralizers after some period. So going on, we wanted to try these centralizers on a larger scale, so we went back to the government and asked if you can test some of these in Salima district in one of their development locations, DA Kambwiri. So Salima gave us a nod to do that. But before then, we had a stakeholders workshop meeting, which was held on 15th of July, where we just had to introduce the load centralizers to the national government, and the consent was given to us to demonstrate how these centralizers do perform, and the consent was actually given to us to do this test in Salima. So the Pro-Secretary for the Minister of Water and Sanitation approved the request and to test the Poldaw centralizers. So subsequent meetings had to be arranged. We had to now engage the district council. So we, on August 2nd, we engaged the district coordinating team for WASH, where we, as an organization, we got recommended to the higher committee for approval to implement this project. So DEC meeting was scheduled, and it was done or conducted on 9th of August, the same month, and we got an approval to do the project. After that, then on 21st of October, we started the implementation together with the district council. So the project was aimed basically that over the next year, the centralizers will have to be monitored in conjunction with the government stakeholders, and this is just to demonstrate performance of the load centralizers to the government officials, so that they can have hard data on how these centralizers perform. So lessons will be drawn from implementation, will be drawn from the exercise, and feedback will be given to both the communities as well as the area mechanics and communities, and the government. So before we had to engage these, to start implementing the project, we had to, like I said, we had to have several meetings, and this picture shows one of those meetings, the DCT meeting. And the second picture shows me presenting the same project goals to the district executive committee that gave us an approval to roll out the project. Yeah, so before implementation of the project, we had to conduct an orientation with government staff from the Department of Water, as well as the area mechanics we had planned to work with on the project. So in the picture, you see the district water officer for Salima demonstrating how to fit on the centralizers. So the next day we went on to the field, and before we started everything, we had to engage the community. So you see one of the government staff from Salima District Council, the lady in the picture, engaging with the community and introducing the project to them. So work had to start. We had to pull out the old parts from the boreholes. So these are some of the old rubber centralizers that we had pulled out. You can see how much wear was on the centralizers. Just to also demonstrate that we had to work with the government or collaborate with government, this is another staff member, the guy in white shirt, also participating in the installation of the new centralizers. This next picture is a picture indicating our community members also taking part in the installation. As you know, Afridev pump is a village level operation and maintenance pump, so we had to engage our community members to be able to do or to install the centralizers. So this is the demonstration that we worked or engaged with the community members. This is just a video to demonstrate how the community members would fit in the centralizers. Just a few minutes.
Nangatana kuti amene ajoka apita kolanda chimanga abwera
So in the video, this is a committee member, a water point committee member, demonstrating that she's able to fit in the road centralizer. So as we're going on with our implementation, these are some of the parts that we had removed from one of the boreholes. You can see how much money this community had spent just to repair the Afridev pump because of the rubber centralizers. So that's the end of my presentation. Thank you so much for your attention.
Well, thank you very much, Jeremiah. Jeremiah referred quite a lot there to the involvement of all the various stakeholders involved, and we'll hear a little bit more on that matter in our final talk. But just before that, we're going to have Sandy Pollack's second short presentation on the technical aspect. Thank you, Sandy.
Hello again. I'm going to give you a few more slides just covering some of the technical aspects that haven't been dealt with so far. The black version on the left is the type that we have used successfully for many years now with threaded rods. It was used on the Poldaw pump and also on modified India Mark IIs. The white version in the middle is the first versions of the snap fit design, and these were machined from solid material for prototype and early tests and service trials starting about more than a year ago. And the blue version on the right is the production version, which is an injection molded part. It's suitable for large-scale production, and it has various flutes and cutouts which are there mainly to save material rather than to change the function. The function of the blue one and the white one, they both function pretty much identically. This slide illustrates how the snap fit centralizer is fitted onto the rod. It's first offered up to the rod at 90 degrees and just fits over the rod, and then it is rotated gradually until it is in line with the rod, and as it falls into line there is a slight snap action, which means that it won't fall off by accident. Once it's snapped in place, it is free to slide up and down the rod. Now for the technical aspects. Firstly, the material. It's ultra-high molecular weight polyethylene, a bit of a mouthful, but it's sometimes abbreviated to UHM or UHMW. And it's a relatively modern material. It's only been around for about 50 years or so. It has excellent abrasion resistance and it's very tough. It's particularly good in water. It has very low friction in water. It's slightly buoyant in water, i.e. it floats. It only just floats, but it floats, and that's very useful for us in this application. Quite an important point is that it's non-toxic. It's a material that is safe for foodstuffs, for handling foodstuffs. It's not toxic. Small particles of it in your water are not going to cause any health problems. In fact, it's such a good material and so biocompatible that it's used in artificial joints in the West, artificial hip joints, etc. So it's a very safe material. The cost is a bit higher than other forms of polyethylene, HDPE, high density polyethylene, but the extra performance and wear resistance of it, we figure, is well worth the extra cost. There are some design features on this version, this production version, that I'll draw your attention to. Firstly, it has flutes or cutouts running along it. They're just there to reduce the weight and reduce the cost because it's an expensive material. They don't have any particular function apart from that. It also has chamfers at each end, and that's to make sure that the whole centralizer will not catch on any joints in the pipe, because there are internal joints in the pipe which we know roughly where they are, but after pipes have been repaired a few times, the joints may not be in the places you expect, and it's possible that the centraliser may have to traverse across the joint, those chamfers being that it can do so freely. Lastly, it's a one-piece construction. It is one piece of plastic. We could have designed one that was made of 2 or more pieces of plastic that are screwed together or snapped together in some way. But to have one piece, we felt, was a good design because it can't, what we call, self-disassemble. It can't fall into 2 pieces or 3 pieces in service. It is one solid piece of plastic. My colleagues have already told you about service experience over the last year or more, but I just wanted to make a couple of small points in addition. Firstly, the centralisers tend to bump against the weld as the bottom of each joint. So the top side of the centraliser experiences some small indentations in service. And this is a useful indication. It demonstrates that the centraliser is actually sitting where we intend it to, which is just below the rod joint, and therefore the rod joint impacts it gently at certain points in the cycle. And the second point is that we have seen some mild wear on the outside of the centralisers on just a few severe duty examples. So one thing we plan to do is also pull up pipes on those same installations and cut open the pipes just to check whether there's any significant wear on the inside of the riser pipes. We don't expect there to be, but we feel we should check this to be absolutely certain, and that checking will happen in the next few months. So in summary, we think that the service experience to date is extremely encouraging, and we expect that they will last 5 years or so in the most severe operating conditions where you have bent boreholes or very, very high operational conditions, many hundreds of people using them. And in more typical installations, 10 to 20 years is a reasonable expectation, we believe. Thank you.
Again, thank you, Sandy, for your input there. That's been very helpful to try and set out the technical detail of the component that we're focusing on. We're now going into our final presentation, and many of you have already been putting questions and comments in the Q&A box. I'd encourage you to keep doing that, and we'll come to those shortly. But first of all, we're going to hear from Dr. Beatrice Chisenga, who's with Design Outreach and is going to speak to us now. Thank you.
Good afternoon. My name is Beatrice Chisenga. I'm the Regional Director for Design Outreach. I'm based here in Malawi, which is in the southern part of Africa. Today, I'll briefly talk about the potential impact of the Poldaw floating centralisers, which Design Outreach has designed. Before that, we'll talk about the situation in Malawi, about the commonly used hand pumps, which is called the Afridev. The Afridev is predominant in Malawi, and most communities are using it for the rural water supply. It is believed that we have about 50,000 Afridevs across the country, according to the recent statistics. And functionality is about 78%. So most of the rural communities still depends on the Afridev as their infrastructure for the rural water supply. According to statistics, it is believed that by 2050, the population of Malawi is going to double, which means half of the population will still continue to live in the rural areas and depend on some hand pumps as their source of rural water supply. The key stakeholders in the wash sector, especially for the rural water, of course, at the top there is the ministry, which is really there for policy level, and also then there is the local government. That's where at the district level, where there's much of operational level, where most of the pumps are installed, and then also in terms of capacity building for the rural communities as well. The institutional arrangements, that's the structures at community level. We have the water point committees, which are very, very important as well, because these are the ones who are charged with the responsibility to maintain the rural water supply infrastructure. We also have the private sector, which is the NGOs, as well as some CBOs, which are also responsible or are also supporting or complementing the ministry and the local government. Recently, we have had the CBM, as much as we depend on the CBM, which is community-based management, communities managing their own water source, but there is also the new concepts of professionalized maintenance, which is coming on board, whereby some private sector are also introducing this as part of to complement the CBM, which sometimes has not been very effective. In Malawi, the government is very open to new wash technology innovation, as much as the policy is really encouraging mechanized systems, but we can see that there are some areas where mechanized system may not work. For example, if boreholes are not, the yield is not good enough, certainly it means the hand pumps is the only answer. Not only that, sometimes some of the communities are very isolated, which means mechanization will not be the answer, but the hand pumps will be the one which will be ideal in that context. And in the same vein, Design Outreach has been supporting the government to bring in the innovation for the rural water supply. And the first innovation which was brought on board was the life pump. Since for about 11 years now, life pumps were introduced in Malawi. These are ultra deep hand pumps which can go as deep as 150 meters, made of high quality materials, with the life expectancy of about 30 years and the operations and maintenance of about 7 years. So in the same way, now Design Outreach is coming again with a redesigned centralizers, which we call the Poldaw floating centralizers, which we believe will also be improve the lifespan of the Afridevs in Malawi, and eventually promoting the rural water supply and making sure that everyone will have access to water by 2030. Thank you.
My apologies. I just muted myself instead of turning my video on. Thank you to all the presenters there. Just before we go into discussion, we're going to undertake one more short poll. First of all, well, two questions. First of all, were you aware of the importance of centralizers before this seminar? This webinar. Just a single answer, yes or no. And the closest answer you can get to that, how aware were you about the importance of this problem of centralizer failure? The second question is about your purchasing habits, if you're involved in purchasing or not. Roughly how many centralizers would you, in your program, be purchasing in a year? There are various ranges given in those questions. So please do go ahead and fill in those two short questions in the poll. We'll just give you a moment to do that. And could you also be entering questions in the Q&A rather than the chat box? And we'll come to discussion shortly. So we've got some results. it looks like slightly more of the audience were less aware of the importance of centralisers as a breakdown, a failure issue. So that's, in a way, that's encouraging, because it means that this awareness perhaps has been raised by the webinar. In terms of purchasing, the numbers are looking quite small. Many of you not involved in purchasing, or not directly involved, but some involved in small numbers, relatively small numbers. Bearing in mind that the normal installation would be one centraliser per pump rod, and if a typical hand pump might have around 10 pump rods, we'd be looking at 10 per installation. Yeah, we're not seeing much representation in this audience of large-scale purchasing. So we'll just close there. I would invite you to put your questions in the Q&A box at the bottom of the screen. Just a couple of introductory remarks before we go into the discussion. In many respects, we're doing something today which is quite unfashionable. We're talking about the importance of the technical aspect of rural water supply, and within that, the possible potential impact of innovation, technical innovation in improving functionality. I say it's become unfashionable to talk about technology and talk about technical innovation, but I think if we only have to pause for a moment to realize that no water supply can function at all without the physical hardware, the physical infrastructure, the pumps, the pipes, the taps, the hand pumps, and so on. We will no doubt, towards the end of the discussion, return to the question of where technical innovation fits in relation to the many wider aspects of management and financing and so on of rural water services. But I think for the time being, there are probably plenty of questions about the innovation that our speakers have addressed, namely that of improving the centraliser, one single component of a hand pump, and trying to make that more reliable. Now, I've seen a number of questions about cost and availability and the wider availability of these new parts in other countries apart from Malawi and Uganda. I'm going to perhaps ask Michael if you'd be willing to pick that up in an answer now.
Yeah, what was the exact question, Richard? Thank you for moderating.
Yeah, broadly, questions about the likely cost as it becomes available on the market, the availability within the countries where the testing is carried out, and the availability beyond in other countries. I've seen in the Q&A mention of Kenya. There's an interest from West Africa as well. So yeah, if Michael or Luke, you can pick that up, that would be great.
Yeah, I'll defer to Luke on that one since that's his expertise.
Excellent. Thanks to everyone, presenters, moderators, all the participants. This has been excellent so far. Yeah, as we think about the best way to make the biggest impact possible, we've identified Malawi as our home base. Part of that, a big reason, is because of our field office. there, the testing that's been done, the piloting that's been completed, and that's really a place where we've been for a long time. But as you picture us moving out of Malawi into other parts of East Africa, we're going to strategically move into other countries fairly quickly within the early next year. Countries we've identified include Ethiopia, Mozambique, Kenya, and a handful of others. As you can imagine, our goal and our aim is to reach as many people as possible. We believe very strongly in the centralizer upgrade as a clear solution to a problem that's existed for many, many years. The reality is some countries, as many know on this webinar, are more filled with India Mark IIs and not with Afridevs. And there can be more discussion around that as we have launched and are continuing a project to bring upgrades to the India Mark II as well. So countries that are East Africa, high Afridev saturation, that's going to be our first. So that kind of covers off on countries. I can now move into pricing and distribution as well. Is that all right with you, Richard?
Absolutely.
Okay, great. So from a distribution standpoint, we're currently taking pre-orders, and I'll be putting information into the chat box with my personal email and then also a website, design outreach website where you can order. Right now, we are saying that we will handle these one-to-one, mostly through NGOs and other nonprofit partners. The goal will be eventually to have broader distribution through local markets, through distributors in country, and really start to build out more of a network where this piece and other upgrade pieces are easily accessible. Currently, we are doing one-to-one custom orders, as I mentioned, and so you can reach out to us with the information we'll provide here shortly. Now, from a pricing standpoint, the current centralizer, if you were to purchase the rubber one that we've seen that breaks down and it is not successful, that cost around $1. And as we thought about the price and what it takes to bring this to market and the value that it holds, we've landed on $5. So $5 US is the cost per centralizer. And you start to look at a return on investment calculation, and that $5 may seem like a larger price. It is 5 times as much as the current one. But as we've shared and as we've proven, these last 5 times longer. So 5 years, and some on the team believe it could be 10 or up to even 20 years for these. So we see the amortization rate, we see the investment paying off. And as we've tested this and floated this with other organizations, the $5 price point seems to be very acceptable. Now, one caveat I will share is that $5 is our retail price. So that would be if you're buying these as an NGO. We are also looking into distributors and other partners who could buy these at a wholesale cost and then include a markup on that cost. So that includes retailers, different distributors, and so we're open to those discussions as well. One final note in terms of the cost, we are looking at price breaks as we get into larger orders. So those will be custom, but if you handle many water points, we can look at potential price breaks on those as we get to larger quantities. So we're excited to bring this to market. We're excited to work with the great people on this call and beyond, and just grateful for everyone who poured into this to bring it to life.
Thank you very much for that answer. This may be another one to stick with you, Luke, or maybe go back to Michael. But the question about intellectual property and whether or not the design will be in the public sector, or will it be patented, and that patent held by an organization, be that a not non-for-profit or a commercial organization. What's the situation? What's the plan on that front?
Yeah, I can take that one, Luke. Very good question. So this Poldaw floating centralizer is not patented. and eventually it will be in the public domain. However, we feel it's very important for the first several years to ensure the quality of this component. So we will be the ones doing the manufacturing initially and making sure that the quality control of this is to a very high standard. Thank you. Good question.
Directly following from that then, Michael, there were questions about quality assurance and quality control in relation to national standards and quality assurance procedures at country level. How do you see that playing out?
Yeah, well, very good question. Again, thank you for that, and thank you to all the amazing questions coming in, and they're very good ones. So I'll make a start here and maybe see if Beatrice wants to add something to that. So we are definitely working directly with the Ministry of Water as we start piloting this Poldaw floating centralizer in Malawi. So we have meetings with the Ministry of Water, and we are piloting with their direct involvement as we move into areas. And that's one thing we're asking for is for more people to help us pilot here in Malawi. So and we're able to sell these to partners in Malawi as part of a 6-month government pilot. And as Luke said, we're now taking pre-orders, and we're expecting additional inventory in February. And what we'd like to do is increase our sample size to at least 250 sites. And we are seeking NGOs that would be willing to help pilot with this. So Beatrice, would you want to add any more to the whole process and relationship with the Ministry of Water there in the Malawi government? Let me see if Beatrice is.
Thank you, Michael. I think most of the things you have already responded to. We are not working alone as an NGO, but we are working hand in hand with the government. I'm sure if the product is getting out of quality, the minister will be able to quickly be able to point that out. And I think another important thing is what Sunday had said, that the quality of the material is edible, such that it is even used in the orthopedics when they may, in hip surgery areas. So in terms of quality, we believe that the centralizers should be as safe as possible. Thank you.
Thanks very much for that, Beatrice. A couple of questions or a couple of answers maybe from Harlod and Jeremiah. There have been some questions about the role of the borehole construction and the water quality found in the borehole, and the extent to which those factors, which we know do vary from location to location, might affect the speed of wear of a centralizer, or indeed any other component of a hand pump. But Harlod or Jeremiah, from your observations in the field, have you seen any evidence that the centralizers wear more quickly in some boreholes than others? And if so, can you put that down to problems of construction of the borehole or problems with water quality in the borehole? Or maybe it's other factors like the number of people using that water point. I don't know what you've seen. Harlod first, maybe.
Thank you very much, Richard, for your elaboration on the question. Basically, for us, we haven't seen any verticality impact on the floating centralizers wear. So far, we have installed over 140 centralizers, and then after inspection of these floating centralizers, we have not seen any impact on the verticality of the water points. But it's a good point to note. I think we'll be observing as the pilot continues. Thank you very much.
Thanks, Alad. Jeremiah, anything from you on that question? You're muted, Jeremiah.
Yeah, thank you so much, Harold. You've responded correctly, but I just want to add that indeed we haven't observed any signs that there is a problem with the verticality of the boreholes. But suffice to say that the long body of the centralizer will help us notice if there is that issue of verticality, because the way I will tell if there is a bend in the installation of the riser means. On high use, we have observed like the two boreholes that we installed in Zareka. The high use is evident on the how the wear is on the road centralizers, and this is also a very good parameter for us to actually confirm how effective these centralizers are. So I think that's what I can say for now, but we'll keep observing. So I think there'll be so many things that we'll have to look for so that we confirm the effectiveness of the centralizers. Thank you.
Thank you very much. And both to you, Jeremiah, and also to Harlod, there's been an additional question about perhaps depth limitations. In the field trials that you've done, have the borehole depths all been fairly similar, or have some been quite deep? And if so, have you seen any difficulties with those deeper installations, or not?
Yeah, Harold, you can come in first.
All right, thank you very much, Richard. For us, there is a variation in terms of the borehole depth. For the 140 hand pumps, the depth ranges from 30 to 60 meters deep, but with an average of 10.5. So for us, we haven't seen like any differences or difficulties with the installation, but it has been an issue of fitting the floating centralizers to the required depth or to the light depth that we have found on the pump.
Yeah, just to concur, the boreholes have different depths. But since we are looking at centralizers, we are looking at the number of rods. So we have installed in boreholes that have rods ranging from maybe 14, should be 14 to 6 rods. So there is that variance. There hasn't been any significant difference in terms of wear patterns depending on depth. Like we said, we are still observing, so probably we'll be able to give more feedback in the subsequent months coming. Thank you.
Yeah. Thank you so much, both of you. Maybe I could invite Sandy to just come in now and summarize a little bit on any of the other technical questions that have been raised, or any comments you'd like to make on the technical aspects of the centralizer. I've got a couple of other questions that people have raised that I'd like to come back to after you, Sandy, but maybe we can go to you first.
Yes, thank you. The question that was just raised was the depth of the installations, how deep we've been installing these. I can also report on the Uganda experience, where we were deliberately testing on pumps that were deep. So our average was over 15 pipes, and some of them were 18, 19 pipes or rods deep. And again, we've had no problems on about a year's testing on 100 pumps with all deep installations in Uganda. And that is the simplified black centraliser, but it works in exactly the same way as the blue centraliser we're discussing for the Afridev. That was probably the only point I wanted to raise at the moment, but I'll come in more if there are other questions.
Okay, thank you, Sandy. There is a wider question that a few people are raising, and that is about other components of the pump, which we haven't explicitly talked about today, but one or two mentions of the cup seals and bearings and so on. While you're there, Sandy, would you like to comment on those ambitions? And then maybe we go to Michael to say a bit more as well.
Thank you, Richard. Yes, we've got quite a strong view that quite apart from preventing other breakdowns due to particles of rubber falling down, we can also extend the life of some components. We have an example at the Zuleika installation that Jeremiah mentioned, where previously, before we installed the blue centralisers, the pump seals were failing roughly once a month. Since installing the centralisers, the pump seals had not been replaced, and at 5 months old, they were still fine. So that indicates that on that installation, at least, the centralisers have had a really big benefit on the plunger seal life. And that may also apply to valves and other components. So we are hopeful that the centralisers have a large, what we call knock-on effect on reliability.
Thank you, Sandy. That's very encouraging. Michael.
Yeah, thank you, Sandy. Sandy pretty well said it, but just to reiterate what he said, we have engineers at Design Outreach working on these other components to be upgraded, like the handle bearings, looking at other options for the plunger seals, and so those are being actively worked on. And keep in mind that this Poldaw floating centralizer is very exciting. Like Sandy said, we would expect it to solve a huge number of issues with the current Afridev black rubber centralizers falling down and plugging up the plunger and foot valve. But keep in mind, this is just the first component to be launched of what we call at Design Outreach, the Afridev Max Life Upgrade Kit. And so we certainly want to keep you posted on how that moves out, but the testing of those components will be ongoing this next year as we bring those to light. So thank you very much.
Thanks, Michael. Yeah, that's great. Just one question from me, and it's kind of circling around to the beginning of your presentation, Michael, when you presented the results of your questionnaire survey on the frequency of breakdown of fast-moving parts, and many of them were over a year and 3 years plus.
Yeah.
In this webinar, we've been hearing examples of very frequent breakdowns, even down to a month or two. And I just wonder if you have any comment on the apparent mismatch between some of those answers in the questionnaire and some of the realities that we've heard described from the field.
Certainly, Richard. Well, we certainly appreciate all those who have responded to the hand pump upgrade questionnaire. And, we showed an average life of 3.5 years for the Afridev centralizer. And the last slide that was transitioning to Sandy's talk, I wanted to comment a bit more. I think maybe part of that was missed on the PowerPoint presentation, but I wanted to answer the question. So why did we focus first on the Afridev centralizer, improving its material and design? And that's because when we started working with partners in the field, such as Fisherman's Rest, Mazialipo, Harlid, Victor, and team. What we found is that some of their experience showed that these centralizers are wearing out and starting to crumble much faster than we previously thought. And another example that Jeremiah mentioned, the one borehole there in the Zalika refugee camp, they installed the new Poldaw floating centralizers last May, and even though it showed some wear after 5 months, he said he found out they had been replacing the old centralizers every month, and they had been replacing the plunger seal every month. And after 5 months, they didn't have to replace any centralizers, and they're still good to go. They put them back in, and that we would expect them to last even longer. So it's showing how the knock-on effect on this particular pump of the seal failing was actually solved with this new centralizer. So thank you.
Thank you very much, Michael. Yeah, that's great. Well, look, we're coming towards the end. I've just got a few remarks, which may be helpful or not. We'll see. But it does seem to me when you stand back and look at the bigger picture, and the question that this webinar asked, can a technical innovation really improve functionality? Functionality is what it's about. And we rightly bemoan low levels of functionality around 60, 65, 70, even in the 70%. It's not good enough as a way of serving rural people. And it's interesting when you think about something like 75% functionality. 75% doesn't sound too bad. If you got that in an exam, you'd think you were doing pretty well. It's okay as an exam score, but it's rubbish as a functionality score. What it means is that on average, each hand pump is spending 3 months out of service every year, and that's simply not good enough. I wrote a paper 20 years ago now, more than 20 years ago, in which I suggested that we ought to be looking at 98% as the target, a maximum of 1 week of downtime per year on average. And to achieve that, I think we can demonstrate that it is achievable, and technical innovations like this can really help on that journey. But we need a whole lot of other things to be in place simultaneously. We need good, robust technology that's going to last, but we also need sound management systems, good monitoring, a financial arrangement that works, whereby the funds are available for replacement parts when they're needed. We need security from theft, for example, absence of political interference. Many things need to be in place. But when all those things come together, then a technical innovation like this can really provide that boost towards that final 98, 99% functionality, which we're all should be aiming at. So it is a key part of the bigger picture. We've heard some very encouraging evidence from the field, from our various presenters. We've heard ways in which that evidence has been received by the different stakeholders, by the water users, by government, local and central. And all of that is part of the journey towards higher functionality, and therefore a more sustained water service that has all the social, health, educational, and related impacts that we're looking for. So I'd like to just close at that point. I'd like to thank all of our speakers, all those who presented in this this webinar: Michael, Sandy, Harlod, Jeremiah, Beatrice. I think you've really come together to present a very compelling story. And thank you all the participants. We've had at times about 150 or more participants in this webinar, and that's fantastic. So take the message out and watch this space for when the centraliser is available and there to be used. Thank you very much, everybody.
Thank you, Richard. And I think there are just a few more slides coming up. And thank you, Richard, for the excellent moderation of this webinar. And again, a thank you to Aline, Batimus, Sean, and the RWSN team for making this webinar possible. And another thank you to everyone who has joined. Thank you so much for your interest, your questions, and your future partnership as we all work together to help make these public domain hand pumps more reliable and have higher functionality and reach more people. So thank you very much. And just remember, this Poldaw floating centralizer, just the first component to launch of the Design Outreach Afridev Max Life upgrade kit with bearing upgrades and like plunger seal upgrades and that sort of thing coming out later. So thank you again. And if you can go to the next slide. So following are some other webinars in this RWSN series. So please join those as well if you can. And thank you again so much for joining today, for each one of you taking time out of your day to talk with us about this exciting new development in hand pump reliability. Thank you very much and have a good rest of your day.